Hello, how you doing? It's Mr. Do the Math here, and today we're going to talk about using long-term planning to achieve a financial goal, i.e., solving for the principal, right? So basically, we're calculating what it takes to get a goal, like to find A. If we have an A value, how much money do we need to deposit, either quarterly, semi-annually, or monthly? Okay, so let's look at our first example here. All right, so basically, by solving an annual formula for P, we can determine how much money should be deposited at the end of a compounding period. Okay, that's what I just said. So let's look at a situation. Suppose you, once you get out of high school, you want to save $20,000 over 5 years, right? To use for a down payment on a home, which we'll be buying in 2 more sections, right? You anticipate making a regular end of the month payment, right, into an annuity that compounds 6%, right? That gives 6%. All right, so basically, our goal is $20,000, right, after 5 years. So that's A. We want to make $20,000 after 5 years into an annuity that gives you, what did I say, 6 or 7%? 6%, right? After we make payments monthly, right? We're going to calculate, we're trying to find P. What is P? Right? So how much money do I need to deposit every month for 5 years in order to accomplish the goal of $20,000? That means you have to use a new formula. That formula is P equals A times the rate over N all over what was at the top. That's going to be 1 plus R over N to the NT power minus 1. Okay? That looks a lot like our last formula, except P is in place, right? So again, what does P represent? The principal, right? A represents what? Basically, right, the goal or the annuity amount. R is the what? Rate. N is number of payments. Right. Right. So, let's do it. So, we got P equals A, 20 stacks, times 0.06 over 12, all over 1, that's 1 plus 0.06 over 12, raised to the NT power. I'll put NT first. So NT is 5 times 12. 5 years, 12 times a year, minus 1. Right? Let's do it step by step. Okay, we're going to follow order of operations. First things first, we're going to multiply these two. But what I think we want to try to do is change 0.06 over 12 to an actual number. All right? So 0.06 divided by 12 gives us 0.005. So now we know, right? So this is 0.005, that's 0.005. So when we go to the next step, it'll be 2,000 times 0.005 all over 1.005 to the 60th power minus 1. Does everybody understand where this came from? Yes, sir. We good with that? We understand where 60 came from. Okay, cool. Let's go.
But that should be 20,000, not 2,000.
It should be 20,000. Right. So 0.005 times 20,000, thank you, is 100. So it'll be 100 over, we'll just leave it like it is right now, 1.005 to the 60th power minus 1. Okay? So we're done with the top. We're done with the top. Let's deal with the bottom. All right, so that is 1.005 to the 60th power, which gives us 1.34 and some change. Yeah? So let's rewrite it. Now I want you to make sure that you do not round. So just leave it there. So we did this divided by this raised to the 60th power, right? The next thing you do is say minus 1, right? Then we get we'll get 0.34 and some change, right? And so from there, we'll do 100 divided by answer, right? Everybody should have an answer button on their calculator, all right? And you'll end up with $286.66. Now, when we talk about solving for P, what you always want to do is round up. No matter what the decimal is, or no matter what the change is, round up. So even though this is 6, if this was 4, we'll round up to 287. All right, $287. Okay? Now, the next question they want to know is how much money, if we get into $20,000, right? How much money is actually going to come from our deposits and how much money is actually going to come from our interest? All right, so what we'll do is we'll go back to our interest formula. I equals A minus PNT, right? P times number of payments times time, right? To figure out what the interest is and to also figure out how much money went towards the payments. So there's 20,000 minus P, which was 287, times N, which is 12, times T, which is 5, right? So let's do it. 287 times 60 gives us 17,220, right? So 17,000 of this money is paid by me, right? That's how much we paid. That came from our principal. And then when you subtract 20,000, when you subtract this from 20,000, you get how much the bank paid, which is 2,780. This is how much interest was. Okay, so this is how much the bank paid. This is how much we paid. Okay, so again, we use this formula to figure out how much we have to deposit per compounded payment, right? And then once we do that, we'll go to the interest formula to figure out how much money of the goal was paid towards, was given from interest, and how much was actually given from our pockets. All right, so that's that. Everybody good so far? Let's try another one. All right, here we go. Do you want me to keep this up? I'll keep this part up. I'm gonna come over here. All right, so look. Next situation. All right, I just had a baby girl, Harper, right? I found a bank that's gonna give me 9%, right? It's gonna give me 9%. I'm trying to save $100,000 for her college plan, right? All right. So by 18, she'll have $100,000 in the account, right? I found an institution that gives us this, and I think and I have to figure out how much they're gonna pay monthly in order to reach this goal, right? This is from the book. This is from the book. But once I find somebody that's got a 9%, then I'm for real. I do got something in place, but I don't think it's 9%. But anyway, so here we go. All right, the goal is $100,000 in 18 years. The institution's gonna give me 9% interest, right? So paid monthly. So let's do the math. Here we go. P equals 100,000, 0.09 over 12, right? All over 1 plus 0.09 over 12, right? Times raised to the 18 times 12 power minus 1. Okay? Everybody good so far? All right, first things first, let's change this 0.09 over 12, right? Here we go. 0.09 over 12 gives us 0.0075, right? So we got 100,000 times 0.0075, right? All over 1.0075 raised to the 18 times 12 is 216 minus 1. All right. Okay. next thing, multiply. So we multiply the top. 100,000 times this gives us 750. All over. Let's rewrite what we had. 0.0075 to the 216 minus 1. Okay? Now, 1.00, how much is it?
186.
That's it?
And 44 cents.
Oh, yeah, good. Yeah, you went too fast. Alright, so we gotta break this down though. Okay, so this raised to the 216 power gives us, let me go back. Alright, so 1.0075 raised to 216 power gives us 5 point something, right? So 750, who's doing math with me? That gives us 5.0 something something, right? Alright, so clear. 0.10075 raised to the 216 equals 5.022, right?
Yeah.
Minus 1 gives us 4.022, right? So now we got 750 divided by 4.022 and some change, right? So do 750 divided by that, you get 186.44. Remember, as I said earlier, always round up. So we need to deposit $187 monthly. That's not a lot, right? Just what you should have got. What did you get?
I got 3,000.
That's a lot.
Yeah, no. Do it
It was
again.
fine until I did the 750 divided by my last answer.
What's your last answer?
It was 4.0226 numbers. But I put in the second negative sign.
Put in a second negative sign?
Yeah.
Alright, let's do it again. But you should have got 187. We'll go back to it. So you gonna pay $187. Y'all spend that on frivolous clothes and food, right? Yeah, clothes you don't really need, right? $187. Just once a month, right? How many times you get paid a month? Twice, right? So you can pull that from one check, or you can take half from one check and half from the other. It's like $60-something,
Nobody gonna say it like
right? Or $90-something, huh?
that. It's hard to say it like that.
What? Take $90 from both your checks?
No, I'm just saying like over time.
So get it automatically deposited into the bank, so you don't even see it. Yeah. All right. So now, of the $100,000, check this out. Of the $100,000, how much is actually coming from you, and how much is actually coming from the bank, right? So that would be P. So it'd be 187 times 216, right? NT, right? So 187 times 216 gives us 40,392, right? So we only paying 40,000 over 18 years. We only paying 40,000 into this, right? The bank is gonna give us 59,608. Yeah, so that's why I said 9% is solid, right? 9% is solid. So the bank is giving giving Harper 59,000, and I've only paid 40,000. All right. So this is how we use long-term planning. So like if you can come, like, so people do it all the time with vacations, right? They say a vacation costs this much, right? Our vacation is in 6 months, right? Or is it next year? So how much do we need to put away every month in order to have enough for our vacation? There it is. Yes, ma'am.
Okay, so say you got like $1 million, right?
Yeah.
If you just put that, like the whole 40,000 in the bank and let it sit for 18 years, will it collect the same interest or that you want to look?
You would probably have to do it monthly. So like, yeah, that's another reason that's what helps it grow, right? You made 216 payments, right? right? You make 216 payments of the same amount. Now, if you set $40,000 in there, just for 18 years, I don't think the bank wouldn't give you that interest rate. Cause like you gotta also think about it, like you're giving the bank money, and so the bank is also making money off your money, right? And because they keep making money off your money, they're gonna give you a little bit of that money. All right. All right. Any questions? No. All right. So, if you had no questions, like if you had any questions, if you do come up with any questions, make sure you comment below. Don't forget to like and subscribe. Let's do the math.